Hey all, so another shape that we are going to cover in our area volume units is going to be triangles. So we've covered a bunch of triangles in the past. You know how much I love triangles from class. I think that they're one of the coolest shapes. But in terms of finding area, and then eventually that will lead us into surface area and volume of 3D figures, triangles have two dimensions, a lot like the other ones we've talked about. They have a base and they have a height. The height is essentially the altitude of a triangle. And remember that the altitude starts at a vertex and it is perpendicular to the opposite side. And then it has a base, which the base is that side that is perpendicular to the height. So they do intersect each other, the height and the base in this case. So the formula that we are going to use is that it's 1/2 times base times height. Now notice that it's really similar to that of a rectangle or even a square, in that we said a rectangle was half of the base times the height, or length times width. The reason that it's half is because a triangle is just half of a rectangle or half of a square or some sort of half of a parallelogram. So that's why we consistently see this formula being used, base times height. But for triangles, we're going to apply half to it. So let's look at a few examples. For both of these, we're going to be, so find the area of the triangles. So I'm going to do two different problems here. This triangle is going to look like this. And for this one, I'm going to make this triangle also kind of look like that, but a little bit different. Now I'm going to focus on this first one to the left over here first. Let me draw a line kind of separating down the middle here. Oops. All right, so for this first one over here, we have, I'm going to drop an altitude down the middle here and say that that's 5 meters, and that the base here is 7 meters. So if we're using that formula, area is equal to 1/2 base times height. Then my area is 1/2 of 5 times 7. So my area is 35 over 2 meters squared, which is also equal to 17.5 meters squared. Now, the reason that I am putting both of these as examples or as your answers is that because this one here, the 35 over 2, this is really the best, and the reason being is that it's the most precise. Like if this was over a different denominator, it could have a decimal that wouldn't be a nice decimal, so you would have to round it off. But then this other option here, this 17.5 meters squared, this a lot of times works if you're doing like a word problem. So word problems, you don't want to like tell somebody, oh, this painting here has an area of 35 over 2 if you're going to be cover that with paint. So sometimes it's more applicable to use decimals than it would be to use fractions. So it just all depends. The best answer is a fraction, but if it's a nice decimal, that's really acceptable too. Now for this other one over here, I am going to do this. So for this shape, I've got a right angle up at the top. This is 6 yards. This is 8 yards. And this is 10 yards. Now, notice that this is a right triangle, right? Right triangles are kind of special in that there's some uniqueness when you're finding an area, because for a right triangle, if we're always using this formula, 1/2 base times height, in a right triangle, your two legs, they are your base and they are your height, because one of your sides is the altitude. So like this side here, I could call my altitude, and then the opposite side there, I could call my base. They're always perpendicular to each other, just like in the last problem that we saw. So my area here is going to be half of 6 times 8. So my area is 24 yards squared. So in right triangles, your legs are your altitude and your base, or your base and your height. So those are two pretty standard examples there. I'm going to add one more example that adds a little bit more depth to this, and just more so the solving of the algebra piece. So find the length of the base of the triangle. So I'm going to draw this triangle here. And then my altitude, I know it doesn't look perfect, but that's okay. Let's just imagine that that's right. So here's my altitude. It's 7√3 millimeters. And then the area of this triangle is 49√3 millimeters squared. So we are trying to find the base here for this. So in essence, we're trying to figure out what is this length here. Now we know that for our shape, because it's a triangle, it's half of the base times the height. So let's apply what we have, the 7√3 and the 49√3, this being A and this one being my height here. So 49 square root 3 is equal to 1/2 times, let's do 7√3 first, and then times the base here. So first what I'm going to do is I'm actually going to divide by 7√3, because we're trying to solve for b. So divide by 7 square root of 3. The cool thing is that the square root of 3's are going to cancel out. So it's really 49 divided by 7. So that gives me 7 is equal to 1/2 times base. And then the way that we can get rid of that half, rather than dividing by a half, instead of dividing by a fraction, I can multiply by the reciprocal. So I'm going to multiply both sides by 2. And then I get 14 is equal to the base. So maybe we write that out. The base is 14 millimeters. I brought this example in because I wanted you to see solving for a given side length given one of the sides and your area, and also a little bit of the algebra review with throwing in some radicals there into problems. So make sure you copy down these notes into your notebook. We'll be talking about these the next day in class. As always, make sure you hit the like and subscribe buttons. I'll keep putting videos up as long as we're not in class, but